So we're at Go Math Lesson 5.5 and we're talking about applying percents and maybe what that would look like as a bar model. So I'm going to show you the bar model because it is a question that's going to show up on your test. If that's something that you like to use, and I've found that most of you don't typically use a bar model, but I want to make sure that that's an option for you. I don't care how you solve the problem, but I want to make sure that you have access to it. So again, if I'm using my percent, I can solve using either a ratio or I can use it as a multiplication problem. So today I'm going to show you as a multiplication problem. Yesterday we looked at it as either. So if I need a stereo, buying a stereo for $100. I know that's not typically something that's done these days, but so I'm buying a stereo for $100 and I have saved up $30. $30 saved. The question we might come across is what percentage have I saved and what percentage will I still need to save? And I made it easy, which is why I chose $100. But if I've saved 30 out of 100, 100 being my total, 30 being there, it's what percent, and again out of 100 because I know that I've saved 30%. So then I might ask myself, well, if I've saved 30%, I know I have $70 yet to go. So what percentage would that be? And I would find that $70 out of $100 is I need 70% or $70 needed. Okay, so that was an easy one because we started with the 100 and we know that percent literally means out of 100. So what if I apply this to something in our book? It might look something like this. Lee has saved 65% of the money she needs to buy a pair of jeans. The jeans cost $24. How much money does Lee have and how much more money does she need to buy the jeans? So this is a two-step problem. Remember, the last step of any problem that we're doing should be to go back and say, does my answer make sense? And what was the question that they were asking me to solve? Make sure that I've answered it, right? So Lee has 65% of the money. Well, let's start with the total amount that the money, that the jeans cost. So the jeans cost $24. And she has 65% of that. So what's 65% of 24? I'm going to do it as a multiplication. 65% is 0.65 or 65 hundredths percent out of 100. Again, we're just going to hammer that home. So she saved 65%. I need to know what is 65% of 24. Well, 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. Add the zeros. 6 times 4 is 24. I'm going to leave that 2 there. 6 times 2 is 12, plus 2 is 14. And when I add them all together, I end up with 1,560, which I know is not correct because I'm looking at something that's around half, maybe a little bit more than half of 24. So I realize I have 2 digits to the right of a decimal in my problem, so I'm going to need 2 in my answer. So she has saved $15.60. All right, so we know what she saved. So there's a couple different ways that we can solve the next part. The question next is how much more money does she need? Well, I could either say, well, she saved 65%, so she needs to save 35%, and I could solve for what 35% of 24 was using the exact same method I just did. I can multiply 35% and find it. But if I already know what she has, I take the total amount and subtract it, subtract what she has saved, because it asked me for not what percent does she still have to save, but how much more money does she need? Again, I'm going back to the end part of my problem, going, what question is it asking me to solve, and make sure that I'm solving that problem. When I subtract them, I have to borrow here, and I have to borrow here. 13 minus 5 is 8, and so she still needs $8.40. So I might say, I'll come over here so we can see it. Lee has saved $15.60, which is 65% of $24. She needs $8.40, comma, or we know that she saved 65%, she still needs 35% of $24. Let me clean up my work here so you can see that explanation. So again, Lee has saved $15.60, which is 65%, excuse me, of 24. She needs $8.40 or 35% of 24. That is an open-ended. That is a great answer. If I wanted to go one step further, I might say I know because I multiplied 65 hundredths times 24 and I got 1560, blah, blah, blah. Might go from there. Now, what does this look like in this bar model that we're talking about? Well, as a bar model, I realize that a full bar is 100%. So what I'm going to do is I'm going to just cut it into 10 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, ideally, you want them to be equal, but they don't really have to be. They're representational. So I know that this is $24. So if that's $24, each of these is $2.40. So I need 65%. Well, there's 10%, 20%, 30%, 40%, 50%, 60%, and then I need a half. And again, if we know that each of these is $2.40, there's 240 times 6 plus another $1.20, and I will get 240 times 6, 0, 4, 2, 1440 plus $1.20, and I still end up with 1560, which was my answer right over here. So this is just kind of a visual way that you can look at this and see if you can make sense of it. So let's just take a quick look at one more. And Jordan takes 50% of the cherries in the bowl, Meg takes 50% of the remaining cherries, and finally Greg takes 50% of the remaining cherries. And there are 3 cherries left. How many cherries were in the bowl before Jordan arrived? This is one where a bar model might really come in handy. I start with a bar, right? And I break up 50%. So this is what Jordan took. Jordan. Now of that, we have 50 more percent that May took. And finally, Greg takes 50% of the last remaining section of cherries. So I just cut each section in half. Yes, you can turn them into decimals and figure out which percentage each person took, but I'm just cutting them in half, and I know that there are 3 cherries left. So this is 3 cherries, which means that Greg also took 3 cherries, which means that May took a total of 6 cherries, and then Jordan took 12 cherries. So how many cherries were in the bowl before Jordan arrived? Well, 3, 3, 3, 3, and then of course we could turn this into 3s as well, but we know there were 12 plus 6 plus 3 plus 3, that's 18, 21, there were 24 cherries in the bowl. So you can see where a bar model does sometimes come in handy to start breaking things into even chunks and make sense of my problems. But again, if you're looking for a percentage, start with what the question's asking you, and then you can multiply, right? So turning your percentage either into a ratio or a decimal.